Hello and welcome to our presentation on requirements gathering and analysis. In the presentation, we'll explain the important aspects of requirements engineering processes, including elicitation, specification, validation, and change. Understanding these concepts is important for the success of any project or system development.
So, what are requirements gathering processes? Requirements gathering processes are the processes used for requirements engineering. They vary widely depending on the application domain, the people involved, and the organization developing the requirements. However, there are a number of generic activities common to all processes. These are the requirements elicitation, requirements analysis, requirements validation, and requirements management. In practice, requirements engineering is an iterative activity in which these processes are interleaved. This is a spiral view of the requirements gathering processes image. This depicts a circular view of the requirements gathering processes. This cyclical approach emphasizes the iterative nature of requirements gathering throughout a system's development. It contains the system requirements elicitation, which is the starting point where the stakeholders brainstorm and identify high-level system goals. The feasibility is conducted. The feasibility study is conducted to assess if the protect goals are realistic and achievable within the given constraints. There is also the user requirement elicitation. This stage focuses on gathering detailed information about what users need from the system. The business requirement specification, which may involve outlining how the system will improve businesses, processes, or add value to the organization. The requirement validation is also seen in the image. This is an ongoing process where requirements are checked to ensure they are completed, unambiguous, and achievable. And lastly, the system requirements document, in which document serves as a formal agreement between stakeholders on what the system will do. Now let us proceed to the two of the initial processes that is used in requirements gathering, the requirements and elicitation and analysis. This is sometimes called requirements elicitation or requirements discovery, in which it involves technical staff working with customers to find out about the application domain, the services that the system should provide, and the system's operational constraints. Requirements elicitation and analysis may also improve end users, managers, engineers involved in maintenance, domain experts, trade unions, and etc. These are called stakeholders. Requirements solicitation is the foundation of any successful development project. It's essentially the process of uncovering the needs, wants, and expectation of all the people involved, including stakeholders, in a project to define the requirements for a system. Software engineers work with a range of system stakeholders to find out about the application domain, the services that the system should provide, the required system performance, hardware constraints, other systems. There are stages in executing requirements elicitation. The stages include requirements discovery, requirements classification, and requirements organization. Requirements prioritization and negotiation, and requirements specification. There are some problems in requirements elicitation. Sometimes the stakeholders doesn't know what they really want, and they express requirements in their own terms. It is also possible that different stakeholders may have conflicting requirements. Organizational and political factors may also influence the system requirements for a system, and the requirements may change during the analysis process, and new stakeholders may emerge, and the business environment may change. This image depicts a circular view of requirements elicitation and analysis. analysis processes, emphasizing the iterative nature of this phase in this system development. As you can see, there are four stages inside the process. The requirement discovery, which is the initial stage that involves brainstorming and identifying high system level goals. Second is the requirements classification and organization. After gathering requirements, they are categorized and grouped based on themes or functionality. Next is requirements prioritization and negotiation. This may involve negotiation and compromise to reach an agreement on which features are most important. Last is the requirement specification. In this final stage, agreed upon requirements are documented in a clear and concise manner. This specification serves as a reference point for the development team and ensures everyone is on the same page.
So next we're going to be talking about the requirements elicitation and analysis process. So first we're going to be talking about the requirements discovery, second is the requirements classification and organization, third is the requirements prioritization and negotiation, and lastly is the requirements specification. So process activities, these include the requirements discovery. This refers to interaction with stakeholders to discover the requirements. Domain requirements are also discovered at this stage. Second is the requirements classification and organization. Groups related requirements and organizes them into coherent clusters. Third is the prioritization and negotiation, prioritizing requirements and resolving requirements conflicts. And the fourth one is the requirement specification, which are documented and input the next round of. So requirements discovery, which refers to the process of gathering information about the required and existing systems and distilling the user and system requirements from this information. Interaction is with system stakeholders from managers to external regulators. Systems normally have a range of stakeholders. Interviewing is a formal or informal interview with stakeholders are part of reprocesses. Types of interview are closed interviews, which is based on a predetermined list of questions, and the open interviews where various issues are explored with stakeholders. So what is an effective interviewing? So be an open-minder, avoid preconceived ideas about the requirements, and are willing to listen to the stakeholders. So prompt the interviewee to get discussions and going to be using the springboard questions, requirements, proposal, or by working together on a prototype system. Problems with interviews include the application specialist may use language to describe their work that isn't easy for the requirements engineer to understand. Interviews are not good for understanding domain requirements. Requirements engineers cannot understand specific domain terminologies. Some domain knowledge is so familiar that people find it hard to articulate or think that it isn't worth articulating. Ethnography. A social scientist spends a considerable time observing and analyzing how people actually work. People do not have to explain or articulate their work. Social and organizational factors of importance may be observed. Ethnographic studies have shown that work is actually richer and more complex than suggested by simple system models. What is the scope of ethnography? So, requirements that are derived from the way that people actually work rather than the way which process definitions suggest that they ought to work. So, requirements are derived from cooperation and awareness of other people's activities. Awareness of what other people are doing leads to changes in the ways in which we do things. Combines ethnography with prototyping. Ethnography is effective for understanding existing processes but cannot identify new features that should be added to a system. Stories and scenarios. So these are real life examples of how a system can be used and are a description of how a system may be used for a particular task. They are based on practical situations, so stakeholders can relate to them and can comment on the situation with respect to the story. So, photo sharing in the classroom in Ireland. So, Jack is a primary school teacher in Ullapool, a village in northern Scotland. He has decided that a class project should be focused around the fishing industry in the area, looking at the history, development, and economic impact of fishing. As part of this, pupils are asked to gather and share the reminiscences from relatives, use newspaper archives, and collect old photographs related to fishing and fishing communities in the area. Pupils use an island wiki to gather together fishing stories and scrap a history resource site to access newspaper archives and photographs. However, Jack also needs a photo sharing site as he wants pupils to take and comment on each other photos and to upload scans of old photographs that they may have in their family. So the next one is Jack sends an email to a primary school teachers group, which he is a member of, to see if anyone can recommend an appropriate system. Two teachers reply and both suggest that he uses Kids Take Pics, a photo sharing site that allows teachers to check and moderate content. As Kids Take Pics is not integrated with the Learn authentication service, he sets up a teacher and a class account. He uses the iLearn setup the service to add Kids Take Pics to the services seen by the pupils in his class, so that when they log in, they can immediately use the system to upload photos from their mobile devices and class computers. So the scenarios, structure form of user story. Scenarios should include a description of starting situation, the normal flow of events, and what can go wrong. Information about other concurrent activities include a description of the state when the scenario finishes. So uploading photos I learned. So initial assumption, a user or a group of users may have one or more digital photographs to be uploaded to the picture sharing site. These are saved on either a tablet or laptop computer. They have successfully logged on to the Kids Text Pics. So normal, which is the user chooses to upload photos and they are prompted to select the photos to be uploaded on their computer and to select the project name under which the photos will be stored. They should also be given the option to inputting keywords that should be associated with each uploaded photo. Uploaded photos are named by creating conjunction of usernames with the file name of the photo on the local computer. So on completion of the upload, the system automatically sends an email to the project moderator asking them to check new content and generates an old screen message to the user that this has been done. So what can go wrong when you're uploading photos? So no moderator is associated with the selected project. An email is automatically generated to the school administrator asking them to nominate project moderator. Users should be informed that there could be a delay in making their photos visible. Photos with the same name have already been uploaded by the same user. The user should be asked if they wish to re-upload the photos with the same name, rename the photos, or cancel the upload. If they chose to re-upload the photos, the originals are overwritten. If they chose to rename the photos, a new name is automatically generated by adding a number to the existing free name. So other activities include the moderator may be logged on to the system and may approve photos as they are uploaded. The system states on completion that user is logged on, selected photos have been uploaded and assigned a status awaiting moderation. Photos are visible to the moderator and the person that who uploaded them. So lastly, we get the requirements for specifications. So the process of writing down the user and system requirements in a requirements document. User requirements have to be understandable by end users and customers who do not have a technical background. System requirements are more detailed requirements and may include more technical informations. The requirements may be part of a contract for the system development. It is therefore important that these are complete as possible.
Okay, so there are numerous ways of writing a system requirement specifications. Here, there are 5 listed ways, but we'll only talk about the first two ones as of now. So, the first one is natural language and structured natural language. Natural language is the most basic way of showing a system's specifications since it can be easily understood by users and customers. Now, natural language is very expressive, intuitive, and universal, which is why I think it's called natural language because it conveys talking as a human being. Now, to achieve natural language, there is guidelines for writing this. So first, when writing with natural language, one should always be consistent and stick with one format. Natural language is also expressive, which is why using words that gives a sense of caution must be used. Words such as should, must, and shall should be kept in mind, since it says here that shall or must make it sound that the steps are mandatory or that you shouldn't skip it in order to not break the machine you're using. And another word such as should is used so that it can convey the person using it would get desirable results. Next is to use text highlighting to identify key parts of the requirement so that it can be less confusing for users and to know which steps should never be skipped in order to not break the machine. Another is since the aim of natural language is to let users and customers understand the system, one should avoid using confusing or complex computer jargon. But I think that in our modern day now, most people understand basic computer jargon such as Wi-Fi or a USB and anything mundane relating to computers. So yeah. Another is include an explanation or rationale of why a requirement is necessary so that we can avoid users with skipping steps and so that they know the importance of that step as well. Now, natural language sounds good on paper, but in practice, it's hard to make instructions clear since users who aren't techie will confuse different requirements together and end up doing more damage than good. I say this because natural language, in its most basic form, doesn't look very appealing to the eye. It's confusing at first look, and you have to really take your time to read it just to be able to understand it. This is an example. Okay, as you can see, there are number the descriptions are numbered, but it doesn't show in a very specific way on why it needs to do it and what field or what step should it be done in. Okay, so while talking to you, I'm trying to read what it's supposed to do, but there's so many things to read that it just ends up confusing me. Now, natural language, which is a way to fix the confusing part of what natural language is. So, structured natural language, it almost looks the same as natural language, but now there's an aspect for the requirements. To put it further, we'll use an example. Imagine in your head a chocolate bar. When using natural language, it's an ordinary chocolate bar with a bunch of descriptions that are hard to understand. But imagine another chocolate with structured natural language. You can see the ingredients are clearly labeled and where it came from and what flavor it should taste like. This is one step further from natural language because of its organized nature, where there are amp descriptions for the machine and for its use. Now, um, before we give out a more clearer example, let's talk about its form-based specifications. Earlier, we talked about having consistency and the natural language being expressive, or why we should use a sense of certain words to show or convey emotions. Now, we'll talk about the specifications in form-based. Now, there are 7 listed here, and the first one is the definition of the function or entity. And The second one is description of inputs and where they come from, description of outputs and where they go to, information about the information needed for the computation and other entities used, description of the action to be taken, pre and post conditions, if appropriate, the side effects, if any, of the function. Now, to make this more clearer, this is how it looks like when we use it. Now, this is one step further, since when you take a minute to read the description, we can already tell what this machine is for. Now, right here is shown as the as comp dose. Comp dose computes the dose of insulin to be delivered when the current measured sugar level is in the safe zone between 3 and 7 units. Now, it's defined here that the safe zone is between 3 and 7 units, and now we can see the how we're going to use it step by step. So first, the inputs. The current sugar reading R2, and then there are the previous two readings, which is R0 and R1. Now think of it as it's going down, and the higher the number, oh no, the higher it is in your view, that's what I think is the current sugar reading is, which is R2, right? So yeah. So source is current sugar reading from sensor. Other readings are from memory. So once the sugar reading um, goes to the machine, the sensor picks it up and displays it, and then the other readings are then stored in memory and then displays it before the uh, the current sugar reading shows. Now, in this outputs, comp dose, the dose in insulin to be delivered, and then the destination is main control loop, which is the CPU, I guess. Now, in action, it will show you basically um, it's how the machine works and how the machine gets the result by rounding up um, by rounding up 4 sugar levels. Oh no, 5 sugar levels, and then if it can be rounded up to 0, then the comp dose uh if the comp dose is set the minimum dose that can be delivered. Now there are the requirements for you to know when you're able to use the machine. So the two previous readings so that the rate of change of sugar level can be computed. Then there's a precondition, which is the insulin reservoir contains at least the maximum allowed single dose of insulin, and the post condition is R0 is replaced by R1, then R1 is replaced by R2. Then the side effects is shown here as none. Okay, so now with tabular specifications, the earlier one was form-based. Now let's look at what tabular specification would look like. Now, for example, the insulin pump system bases its computation on the rate of change of blood sugar level, and the tabular specification explains how to calculate the insulin requirement for different scenarios. So, imagine it as two tables such as this, and then here it says conditions and then the action. The condition shows us how many various events can happen and how we can deal with it with the word action. So sugar level falling, R2 is lesser than R1. It's going to show comp dose equals 0. And if the sugar level is stable, it's going to show comp dose 0 again. Now, for us users, we can look at this and we can deduce for ourselves that, oh, this is how you compute for how the machine would work and how much insulin dosage we need. Okay.
Use cases are included in the DML are a kind of scenario depicting user interactions with the system. They offer insights into system behavior, ensuring all possible user interactions in the system These use cases are represented through high-level graphical models and detailed tabular descriptions, supplemented by UML sequence diagrams to enhance understanding of event processing. This diagram provides an example of a use case in action. As discussed earlier, the use case helps us understand how different parts of a system interact. Notice how it identifies actors and describes the interactions within the system. The software requirements document serves as the official statement of system requirements for developers. It should include both user requirements and system specifications, guiding development efforts, and importantly, it focuses on defining what the system should do rather than how.
For, for the users of a requirements document is a vital part of any software development project. It outlines the features and functionalities that the system should have. But who exactly uses this document? The audience for a requirement document. The requirement document is used by several key players in the software development process. Here are some more important users. System customers. These are the people who will be using the systems once it is developed. They can use requirement document to specify the requirements and read them to check. System managers. Managers use the requirements document to plan a bid for the system and to plan the system development process. System engineers. System engineers use the requirement document to understand what system is to be developed. System test engineers. System test engineers use the requirements document to develop validation tests for the system. System maintenance engineers. System maintenance engineers use the requirements document to understand the system and the relation between its parts. Requirement document variability. Information in requirement document depends on the type of system and the approach to development use. System development incrementally will typically have less detail in requirement document. Requirements document standards have been designed standard. These are mostly applicable to the requirements for large system engineer projects. Structure of a requirement document. A requirement document is also a blueprint for a software system. It outlines what the system should do and how it should work. Structure of a requirement document. The requirement document is typically divided into several chapters, each with specific focus. Preface, introduction, glossary, user requirements, and system architecture. For the preface, this section describes the document's purpose, audience, and version history. For the introduction, this section introduces the system and explain how it fits into the bigger picture. Glossary. This section defines any technical terms used in the document. User requirements. This section describes the features and functionalities of the system from the user's perspective. System architecture. This section provides a high-level overview of the system architecture. System requirement specification. Hmm. System requirement specification. This section dives into details of the system functionalities, both functional and non-functional. System models. These are visual representations of the system showing how various components interact. System evolution. This section discusses assumptions made during design and anticipates potential changes due to future advancement or user needs. Append, appendi, Appendices. This section provides supplemental information such as hardware or database specifications. And lastly, index. An index helps us users navigate the document easily. Requirements validation. Concerned with demonstrating the requirements define the system that the customer really wants. Requirement error costs are high, so validation is important. Fixing a requirement error after delivery may cost up to 100 times the cost of fixing an implementation error. Requirements checking. Validity. Does the system provide the function which best support the customer needs? For the consistency, are there any requirements, conflicts, and completeness? Are all functions required by the customer included? Realism. Can the requirements be implemented given available budget and technology? And verifiability. Can the requirements be checked? Requirement validation technique. Requirement views. Systematic manual analysis requirements. Prototyping. Using an executable model of the system to check requirements covered in Chapter 2. Test case generation. Developing tests for requirements to check testability.
The following are questions that stakeholders should ask regarding a requirement in the system. First, verifiability. Is the requirement realistically testable? Can a requirement be verified through testing and can it conform to the stakeholder standards? Second, comprehensibility. Is the requirement properly understood? Do we have a complete mastery or understanding in regards to the qualities of this specific requirement? Third, traceability. Is the origin of the requirement clearly stated? Are we able to identify the source of the requirement? And can we map the changes that have been made or may be made in regards to the requirement? And lastly, adaptability. Can the requirements be changed without a large impact on other requirements? Can this specific requirement be implemented or updated without compromising the existing system or other requirements? These are questions that stakeholders should ask regarding the system. And if stakeholders should discover complications in the system using these questions, then it should be documented and resolved afterwards. In changing requirements, it is important to consider the following. First, the business and technical environment of the system always changes after installation. Any changes made to the system will affect the environment of the system. New hardware and policy changes may be made, training the staff for the new change, and etc. Changes like that are necessary to accommodate for the system. Second, the people who pay for a system and the users of the system are rarely the same people. The stakeholders and the users are two different groups of people. The developers develop and maintain the system, while the users are the group who uses the system. Therefore, the system may need updates later on to accommodate for better user experience. Large systems usually have a diverse user community, with many users having different requirements and priorities that may be conflicting or contradictory. Similarly to the last one, systems depending on their scale can have an incredible amount of users. Each user will want different things from the system. Therefore, appeasing or satisfying every user will prove to be impossible. That's why the best action for the stakeholders to take is to identify the general consensus of the changes needed to be made to the system without compromising its functionality. This can be determined through many ways, such as a survey. Requirements management is the process of managing changing requirements during the requirements engineering process and system development. New requirements can be required while the system is still being developed and even after it has been deployed for use. This can be due to new technology, user experience, and more. When updating or adding new requirements, it should be noted that dependent links between different requirements should be accommodated to ensure that the existing system won't be compromised. Requirements management planning establishes the level of requirements management detail that is required. Requirements identification. Each requirement should have a unique identification so it is easily searched and unidentifiable, and it can be used to cross-reference with other requirements if need be. Second, it is important to document the set of changes made. This is to assess the impact it had with the existing system and the cost it is required to be implemented. Third, traceability policies. These are policies that define and record the procurement of the requirement and the relationships it has with each other requirement. Fourth, tool support. These are essentially tools that help in managing the requirements. This can range from simple spreadsheets listing the requirements themselves to more complex specialist requirement management systems. Requirements change management. There are three things to assess before a proposed change to take effect on the existing system. First, problem analysis and change specification. Essentially, it proposes two questions. Why does this requirement need to change? And what needs to change with the requirement? Second, change analysis and costing. What will happen with the existing system when this requirement is changed? Will this change compromise the existing system and or affect other dependent requirements? And how much will it cost for this change to take effect? And third, change implementation. Finally, implementing the requirement change and documenting the process. This is a diagram of the step-by-step procedure that I discussed earlier. First, identify the problem that needs to be addressed. Second, problem analysis and change specification. Again, why does this requirement need to change and what needs to change with the requirement? Third, change analysis and costing. What will happen with the existing system after the change and how much will it cost? Lastly, the change implementation.